Welcome, Jacob, again to House Calls Vermont. We have the same clothes on, it's the same background because we're just continuing the same interview. It's not like we're still sitting here a week later with the same. Although who knows? Knowing the two of us.
It's a comfy zip. I wear it a lot.
That's true. But part two. The part two I wanted to start getting into is this really contentious thing in the industry right now, but something that we've been really needing to talk about for a very long time, and that is what are we actually trying to do with these attempts at reducing carbon emissions, right? Because we've agreed as a society here in Vermont, maybe not broader, but in Vermont, we've decided that climate change is real. Global warming is, well, we're calling it climate change because it's not just warming; it's also cooling depending on where and when. And something that Jacob has had on his radar for a very long time is looking at what we're actually doing as far as our building materials and how those either add to or subtract from our stated goals of trying to reduce carbon emissions, and has written books and spoken at conferences, and we're just very lucky in Vermont to have him and Ace McCarlton and others who are working on this. So I wanted to dive in a little deeper and start off by saying, what do you mean embodied energies? What is it that we're trying to look at here? And why is embodied energy and embodied carbon important in our societal move towards trying to reduce our carbon footprint?
Great question. Thank you for the opportunity to talk about it because it is such an important piece that we just haven't really. It's been a blind spot for our industry for quite a while. So just some quick definitions of terms. That embodied carbon is really a shorthand phrase for embodied carbon dioxide equivalent. And that carbon dioxide equivalent really speaks towards all of the greenhouse gases that are emitted from really the entire life cycle of a building or of the products within the building, and all the points of emissions of all the different chemicals, carbon dioxide being one, including methane and a host of different refrigerants that are in some cases thousands of times more potent than carbon dioxide.
On an ounce per ounce basis, yeah.
Exactly. Yeah. So when we say embodied carbon, it's really shorthand for like the greenhouse, the global warming potential of a building or of the products in a building. And that there's a very formal practice, life cycle analysis, that really looks at the entire lifespan of a building from the when.
Wait a second. Did you just equate the lifespan of a building to psychoanalysis?
I know. I spoke too quickly. Life cycle analysis. Although, oh man, does psychoanalysis enter into our work on the regular? That's more client relations. But also internal meetings have a lot of that too.
Yeah.
No, but no, when we're talking about the atmosphere, life cycle analysis, I love that. That's hilarious. That's the like methodology of looking at full life cycle impacts from when materials are extracted out of the ground or harvested from the woods or a field, all the way through the operational phase of the building until the end of life scenarios and conditions and emissions that come from demolition and decomposition of materials and whatnot.
Cradle to cradle, as it were.
Yes, exactly. So that's like full embodied and full life cycle. What we've been working on more specifically, both because it's a little bit of an easier nut to crack, but really because it's what matters right now, are the upfront emissions, which are the emissions that happen in the life cycle of a building prior to it being occupied. And so we're looking largely in where the materials come from within that sort of time frame of reference. And so a lot of that's what we call cradle to gate, which is essentially looking at the products themselves and what emissions and global warming potential is realized from the development of these materials. Again, from getting iron ore out of the ground or cutting that timber down through all the way through the transportation to various facilities and the manufacturing of those products to the point that the product is done and ready to leave the factory gate. And so when we talk about embodied carbon, that's generally what we're looking at, and partially because there's really good data that's available now to look at those products and compare them directly. And the boundaries are constrained enough that we can have a pretty good evaluation standing of like, oh, this board installation is 25 times the global warming potential of this one. And that's like actionable decision-making data. And partially because what we recognize is the global scientific community has flagged initially 2050 as the deadline for decarbonizing our industry if we're going to have a stable planet in which our societies we know it to be able to continue. Now I'm hearing those being revised to like 2030 to 2035, which is an incredibly short period of time. And so when you look at where the emissions are of built infrastructure between right now and that period of time, the majority of them are in the production and development of materials, not in the operation of buildings.
Right, because
and that's
we're
partially
all
because for a
working
long
very
time it was all
hard.
about the operation.
Yeah, we're all working very hard to reduce the operational energy that our building has. That's the whole
Yes,
basis of high performance and passive house and those types of things.
exactly. And we've been really successful. And that work needs to continue. I in no mean to say that we're done and it doesn't matter anymore and it's less relevant. Like, no. Everything we've been doing and more so needs to happen around improving energy performance of buildings.
Right.
And what we're realizing is that's not, and in addition, the environmental impact of our energy production is critical. So decarbonizing the grid
Yeah.
and fuel switching to low emission fuels,
Yeah.
huge, critical, fundamental part of it. Like, yep, all that absolutely. And we have to consider the impact of what it takes to develop our materials as well, partially because it's the largest category within this near period of time, and partially because the scale of those emissions can grow as we pursue improvements in the operational performance of our building. So if we're using more insulation and really high levels of insulation and using different types of air sealing measures and whatnot, and those have really significant climate impact factors, like we need to know that and plan for that accordingly so that we're not erasing all the gains from reducing our operational performance by blasting thousands of tons of refrigerants into the atmosphere in the process through producing refrigerant intensive insulation products. So that's when we're talking about embodied carbon, like that's what we're trying to understand. Like, yes, we're getting a better understanding now than we've ever had around why energy efficiency in building operations is important and why this move towards all electrified buildings and renewably powered grids is really important. And we're saying, and it's not enough.
Right.
And if we were really doing the work we're doing now in the 70s and sustained that from when we started doing this work as an industry in the 70s and stayed there, we probably wouldn't have to talk about any of this embodied carbon stuff. It wouldn't be relevant. It would be a blip on the radar, or maybe we'd have a lot more time to think about it and more options available. But we squandered a whole lot of time and a whole lot of our carbon budget. Yeah. And so now we don't have the luxury of like only looking at operational energy anymore. We really have to think about where materials come from if our actual goal in doing energy efficiency work is to reduce the climate pressure from building buildings.
Right. So tell me,
yeah,
you've got. I remember you came and gave a presentation like 5 years ago to the Northern Vermont Building Science Group with the spreadsheets, and you were looking at all the various bits from that cradle to gate. And it fits really well in with the new framework's idea of natural materials, because those natural materials are very low as far as I understand on that scale of embodied energy or global warming potential, whatever term we want to put there. Tell me, what have you found? I mean, I don't think any of us will be surprised that highly plasticized insulation materials are not doing very well on that scale if the scale is trying to reduce that. So give us just a 30,000 feet view of what your research has found.
Yeah, happy to do so. I'll try to like kind of hit the bullet highlights, knowing that there's like exceptions to everything and a ton of detail, and we're still learning some of these patterns. But some of the patterns that we've seen, structure is a really big deal. It's less of a big deal for low-rise residential construction and light commercial, where a lot of our structures are already, like small wood sticks, and that's pretty light impact, and so that's great. And the structural pressures on smaller buildings are better, but there still is a ton of emissions that come from concrete, and there's a lot of work we can do to reduce the emissions of concrete without costing basically anything, if anything, in many cases saving money by being able to design out waste. And certainly as you get into slightly larger buildings, you start getting into any more steel construction or concrete structure beyond just foundations. Now we get into really escalating levels of emissions from structure. And so paying more attention to structure and structural engineering and structural material alternatives is really important. More apropos towards the sort of home builders and remodelers, kind of residential, low-rise scale work, insulation materials jump out pretty significantly. Partially, again, like I was saying before, because we're using more of them in pursuit of low energy buildings, and partially because some of our worst offenders and our largest spread of impact is within the insulation products division. And we actually have a lot of choice around insulation products, like cavity fill or continuous wrap or foam application. There's like 1,700 different insulation choices out there for how you want to strategize conducting a building. Some of the worst offenders are HFC-based spray foam and XPS foam board have refrigerant or propellants that are the classification.
It's classically called a blowing agent, right?
Yeah, blowing agent. Thank you. Exactly. Is used to formulate those products. Those have some of the highest global warming potential and profiles of any of the chemicals you bring into the built environment. And so those insulation materials are really, really bad from a climate perspective. And then you got a whole bunch of stuff in the middle. There's a lot of foams like polyiso or EPS foam that are like pretty intensive, but way better and more like moderate in their impact. You have mineral wool. It's actually like more than the lower level foams, but not as bad as the high chemically intensive foams that sort of stack out there, because it takes a lot of energy to spin stone into wool. Yeah. And so there's a lot of emissions associated with that. And then you kind of keep working your way down. You've got more bio-based materials, and you have products like cellulose, which is almost entirely from a waste stream. And then you've got agricultural products like straw or hemp that are showing up in off-the-shelf bats, prefabricated panels, custom processes, et cetera. And those, now you get to the point of being able to do active carbon storage, where we're using the fact that these short cycle plants or bio-based waste products, that the 50% of their mass is carbon that used to be carbon dioxide in the atmosphere that's photosynthesized into the body of that plant. And so now we get into the potential of actually carbon storing materials if we can really ensure that they're coming from a well-managed site, and that's a legitimate, they're not creating more emissions than they're actually storing in the plant itself, et cetera, et cetera. So we see insulation materials that offer that advantage. And so, we've had some clear worst offenders. We have some clear winners, and we have a bunch of stuff in the middle. And then there's wood, which is like everyone's really big, like, oh my God, like, in using wood, are we deforesting the planet, or are we storing a bunch of carbon in our buildings? And the answer can be yes, like to both of those, right. Sometimes in the same product. Right. But really ultimately in terms of the larger carbon balance, it totally depends on how that wood resource is managed. And so on an industrial scale, it can be really hard to make sure that that's good wood from the planet standpoint. Here in Vermont, where we're using wood from smaller scale managed plots that tend to be managed for the long term under management plans by legitimate foresters. In those cases, I feel a lot better about the use of wood, but that's a difficult thing to scale nationally. And so we have an advantage of being in a region where that resource is available to us. So we're really looking at embodied carbon in buildings and residential construction. There's some pretty good worst offenders. We can say like, yep, we're going to try not to use those materials because we know they're really bad. There's other ones we can say, these are great. Biobased is really good, and short cycle ag crops like win all the time. Right. Structure is kind of an issue. And then I think the other sleeper hit there is that in cladding and interior finishes, we can see, again, huge pools of carbon or huge pools of emissions, depending on whether you're using bio-based materials or high emission intensive materials. So fiber cement siding is an enormous climate footprint to that material relative to working with native cedar. And so there's we can talk about longevity, durability, maintenance, and aesthetics and all the things, absolutely. But if we're looking at this from the lens of what is the climate emissions from this building, we care about that, we're going to make any decisions around that, or at least want to come by that honestly and understand that, then getting into some of those details of some of the finishing systems, like there's a lot of material that goes on the wall. And again, a really big spread of what the impact of that material is. And so we've been working a lot of recent in terms of like, well, now what? We've been working on better tools to be able to have some reference points of what the worst offenders or best options are and where your preferred materials lie in between. So we can really start with a sense of smell, as well as actually accounting tools that we can bring into our design or construction practice to be able to start doing some of those tallies and doing some of that basic accounting to just so we know what our impact is. It's just what folks in the energy efficiency world have been saying forever is that you can't manage what you can't measure. If you don't know that you're bleeding energy out of somewhere, you don't know whether that valve should be on or that switch should be shut off. Right. So a lot of it is just like we're at the point with carbon now where, embodied carbon emissions, where we're still trying to understand what our impacts are, right, and where are all the big emissions and what are all those big patterns. And so a lot of us that have been more on the bleeding edge of that are trying to do the heavy lifting on the accounting work to really understand, just doing a bunch of like looking at a lot of our buildings and looking at all these new materials and really just trying to dig in and tunnel through and help just make that more evident to ourselves. Because we know the problem is really huge and we know that the emissions are enormous and we know the potential for carbon storage and working with sustainable agriculture and silvicultural systems is in one of the most exciting and like largest potentials for climate action in the built environment is working with bio-based natural materials from sustainably managed land resources. Yeah. Like, oh my God, that's thrilling. Like here we go in terms of like looking, where are the big solutions? Like farming and forestry. Like every rural community in North America should be like trumpeting this from the mountaintops. That here, the solution lies in existing ecological systems of photosynthesis with these industries that are the backbone of American industry since the founding of the country. Right. We should be able to rally around that. So that's a really exciting potential. Now it's just a matter of understanding. We know that's all true. Now it's a matter of like, okay, what's the fastest way to get there? What's the most like, what are the worst things we need to design out? What are the best opportunities we need to throw leverage into? And what are the general patterns around what we should care about? Like, is it worth obsessing over our drywall? Sometimes yes, sometimes no. When, why, how much, what else have we done first? What else should we be paying attention to? It's like that old adage that, if you're worried about moisture in your building, like don't worry about a vapor barrier until you've gotten your window flashing right. And then don't worry about your vapor barrier until you've gotten your air barrier. Like, right? Like there's a hierarchy of importance. And like, we know what that is, energy efficiency. We know we're not going to head into our first weatherization project like, oh, clearly these windows need to get replaced. Like, well, actually, no, because that's really expensive and only saves so much energy. And, there's like, then we've learned some of those patterns after a generation's worth of like full industry weight behind us. We're still working out those patterns so that we don't all have to do the accounting right now. So that's my 30,000 foot.
Yeah, that great. Yeah. I mean, you're in the airplane looking down. So that leads me. You have such a good storyline that I was thinking, where's the tool? And then you started talking about the tool. So my question is, and by the tool I mean, where are you at in having an actual deployable tool for a contractor to be able to take and say, I'd like to take a look at the embodied energy of my materials. Jacob and his team over at New Frameworks have put together this spreadsheet, this online whatever. Is there a tool available, or are you developing one, and where's that at?
Yeah. The answer is yes to both of those. So there are some tools that are out there right now. If you're in the design world, for those of you that are that either work with architects or are an architect yourself and work with Revit, Revit has a great tool called Tally, which does life cycle analysis. There's another competitor, OneClick, which is not specific to any particular design program. So those are the architectural resources that's out there. There's a free tool that's out there for everyone called EC3. That's released by Building Transparency, pardon me. And that is essentially, it's an awesome tool. It's basically a database of environmental product declarations, which are essentially like the nutrition labels for buildings that look at their environmental performance.
It's a
And so
very
they
very big in the building living building challenge. Those yeah,
Yes,
yeah.
that's all about like supply chain transparency and and product transparency to know like, well, what is the global warming potential of this piece of drywall? There's an EPD, environmental product declaration. It's either been released by the company or by the trade group that will give that data. And so EC3 has combined thousands and thousands of those EPDs together in a tool, an online tool that's searchable and allows you to model full buildings or compare between different products. It's more scaled towards larger, like more commercial development. And so it's a little bit intimidating. It's not the easiest thing to use for,
Single family residential.
Exactly. But I do know plenty of folks in the residential market, myself included, that use that tool, and it's a good resource for like, I need to find like, what's a good drywall solution? You can like, you can use it for sort of targeted product research. And if you're more like tool oriented in your nature as a practitioner, then like it's totally usable and approachable. It's free, open source, with lots of good documentation, a strong community of users. So that's something that's available like right now you could get into like today. Athena Lifecycle Impact Estimator is another free full lifecycle tool. It tends to get like not be the best user interface in the world and has a more limited database in terms of potential materials. Like there's a lot of more alternative materials that aren't going to show up there, but it's another great, pretty usable, free, straightforward tool for, again, that's full life cycle. So you're not just looking at global warming potential, you're looking at 7 different impact categories over the full lifespan of a building. But that's, again, something you can use right now. What I'm talking about in terms of the upfront carbon emissions or carbon dioxide equivalent embodied carbon emissions of a building, and really focusing in on that. That is a tool that I've been working with Chris Magwood from Builders for Climate Action for a couple of years now, called the BEAM tool, Building Emissions Accounting for Materials. That emanated out of a thesis, a graduate thesis that Chris did around this topic, and he actually built out this enormous database of EPDs and a working tool for himself for his own research. We then since spent the last couple of years improving and refining, going through multiple levels of revision. There's essentially a working spreadsheet model that exists right now, and the web application is under development to be released imminently. There's the I don't know exactly what the release date is at this point, but we're within spitting distance.
Awesome.
The spreadsheet is pretty much ready to go. And so if you go to Builders for Climate Action dot something, hold on, I can look that up.
I'll get all of the links for all of these.
Yeah, you get the link up there. Builders, Google Builders for like Climate Action, and you can sign up for the release notice on the Beam tool. And that'll be a web application that'll essentially, you can say, you'll input the basic dimensions of your walls, ceiling, foundation, kind of like a super lightweight energy model.
Like REM rate, but for embodied energy.
Exactly. Yeah, your basic building dimensions. And then you can, within the tabs in the tool, you'll be able to see a listing of all the different material solutions for bat insulation, board insulation, interior cladding, exterior cladding, et cetera, et cetera. You can see what the carbon profile is for all those materials based on the amount of insulation that you're asking for and the area of the room, and then click on the ones that you want to specify for your project, and then it'll total them. So you can see the comparative analysis between different options, and then the total of what your building looks like. Because let's be honest, we're still going to have to be putting spray foam in rubble basements forever, or at least for a long time.
Until they
really
develop
not a better way.
Yeah, they develop a non-plasticized spray foam that does the job.
Yep.
There are some places where you don't get better than what that stuff does when it's applied correctly.
Right now, this is kind of what we got for at least right now until some better solutions show up. And so if you're then also going to be touching the above grade walls, touching the attic, reskinning the building, are there other material choices you can make to offset the impact, to balance out the impact of that spray foam? So if you say, like, we want to keep this building to a carbon budget, and you invest more of that budget in the foundation, the point is not to say no foam ever, foam is bad, and come up with like a dozen reasons why there are some serious liabilities or concerns around that material, but then there's another dozen of why it's like actually really important and a good tool in the kit. And so the point of that calculator is to be able to
to
Yeah, no, I think it's
visualize
absolute.
and put
Yeah.
actual numbers behind your feelings about it.
Yes, a data-driven approach to making better climate choices for material selections. And the one thing I will say is what I was saying before, that like, yeah, we're still a little bit green in this work. We don't really have all those patterns identified. We can't just say this is good, this is bad. I mean, I've been looking at this for years now, like pretty intensively, and I'm still surprised on the regular at like what I thought was going to be a big deal is actually not that big a deal. Or what I thought was like, oh, I shouldn't have considered, like, oh, wow, there's like, oh, it makes sense. There's like 7 square miles of drywall in this building. Okay, yep, I guess we should probably pay attention to where that's coming from. And like, do we need 5/8? Because we can go to half inch and 20% of our emissions just went out the
Right.
window,
Right.
so to speak, because we were able to make do with less material, and that's also cheaper. You know, those types of things.
Yeah. Wow. Well, so I am going to get all of the links to the various programs that you spoke about, the online and the others. Is your tool, the Beam tool, going to be a free, or is it going to be something that people have to pay for to use?
The Beam tool right now is designed to accompany a membership as a membership benefit of joining Builders for Climate
Okay.
Action.
Okay.
And that'll be, again, when that, I don't know that part of things. I've been more on the technical side of that development. But the BFCA is being established as essentially as a trades organization, professionals organization of folks that want to see this work progress. And so there's a lot of education, policy, development, research. The work that's happening in that organization is pretty terrific. So the tool, yeah, is designed to essentially be another benefit of membership to that organization that'll allow you your own accounting.
Good.
My understanding is that there's a version of this in which there is a really lightweight kind of free version, and then more features get unlocked with more membership.
Right.
But I'd say stay tuned for the release dates on that for all the gory details when they're finalized.
And I would recommend to any viewers who are interested, Jacob and Ace and what's his name again, the guy from being
Chris Magwood
gave a presentation at the, I believe, 2019 Better Building by Design. The keynote speech was
20
was speaking specifically to this project. So and Jacob and I both have been colleagues. Have been fortunate enough to be colleagues on the RBs, the Residential Building Energy Standard Code Update Advisory Board for the past 3 iterations, and that's an interesting organization and group to be a part of, because of course there's a lot of stakeholders who have competing goals, but for the first time a majority of us did vote to push maybe some points for embodied energy reduction. So toe in the door, as we say.
Yeah. And that work is exploding. The policy level work around national governments, provinces, states, municipalities, starting to bring embodied carbon into their regulatory environment, into the code environment, like that is absolutely happening and is going to be only more and more and more of that. So for any of you policy advocates or policy makers in the room, get on board now. Better to be ahead of this curve in designing policies and systems and structures that actually make it work for tradesfolk to be able to do this accounting in a way that's supported and not just another burden of bureaucracy or administration, but is actually like good tools to make smart choices. That's what all of this is really about. So yeah, keep your eye in that space. Thanks for mentioning that, Chris. That's really
absolutely
a big part of
and really important is that there's a shift in the builders that I've been dealing with for the past 10 years, where things that before they were ha-haing about, like guffaw, these things are no longer guffaws. And so the maturation of the industry towards building science, towards understanding that we have climate goals that we have agreed upon as a state. I did have a guy who wrote this nutty response to something that I had said about, we have agreed upon, he was railing against the comprehensive energy plan. I said, dude, this is done. This is not a debate. If you don't like it, you cannot like it. But let's not renegotiate the comprehensive energy plan goals because they've been part of state law for, 10 years now. And if you have a
Yeah.
problem with that, then it's not with me, it's with the legislators. Go to
Mm,
them, have them repeal the law or change it or whatever. But
right.
when I say we're doing this to fulfill state law, this is a law. If you're a law and order kind of person, either
Mm-hmm.
support the law or
Not law
change the
or
law.
yeah,
So,
or
yeah,
real. Agree with that.
absolutely. Well, Jacob, I'm really looking forward to seeing and playing with some of these tools in the future.
Great.
Part of the Passive House, um, uh, panoply of things that we're trying to point people to. We've been saying embodied energy and global warming potential for forever, so that this is
Mm-hmm.
this is becoming more and more part of the everyday nomenclature. When I hear a
Great.
large local builder say something like embodied energy, just makes my heart sing.
Yeah.
So we're slowly but
Yeah.
surely bleeding from the edge into the
Yep.
mainstream, and
Yep.
your
Yep.
work is not a small part of why that's happening here in Vermont. So I want to personally thank you for those efforts, and thank you for taking time out to talk about embodied energy. And I will have lots of links for people. So that
Chris, thank
is,
you. Real
yeah.
pleasure.
Oh, yeah. Say that. Go ahead.
Thank you so much. It's really, I really appreciate you caring and taking this issue seriously and for opening up the conversation. Really appreciate it.
Absolutely. And I want every person who is a member of the New Frameworks LLC to go to House Calls Vermont and like and subscribe. Okay.
Love it. Great challenge.
Okay. Now
Appreciate
we're
that.
gonna
Let's
have
spread the
a
love.
crew meeting, and you have to go onto your phone. And first things first. Let's get Chris fed.
First things
No,
first.
we're all
Exactly.
volunteer. There's nothing going on here. So this is Chris
No,
West
happy
for
to give
House
you some
Calls
love for
Vermont.
sure.
And Jacob and I can talk for days and not get bored about probably just about anything. So until next time.